Alright, so good morning once again and welcome to our native maths class. Previously, we've learned or we have introduced you to the concept of calculus, where we said that under calculus we'll be looking at differentials, integrals, and limit of functions. So in our previous lesson, we started with differentials, where we look at the basic notations, and then we came to function of functions. We started looking at the various rules. So I think we've done with product rule, the quotient rule. And this lesson we'll be looking at the quotient rule. Okay. Now quotient talks about division. Whenever two functions or you have terms divided and you are being asked to differentiate such function, what you have to use is the quotient rule. For example, if you are being asked to differentiate, let's say the term y is equal to 2x plus 1 over s cubed minus 1. We have the upper term, or let's say 2s plus 1 is being divided by s cubed minus 1. So whenever you are being asked to differentiate a function of this kind, what you have to use is the quotient rule. Or let's say whenever you are being asked to differentiate trigonometry identities or ratios, for example, if you are being asked to differentiate this is sine x on cos x. If y is equal to sine x cos x, and you are being asked to differentiate this function, what you have to use is the quotient rule. And the quotient rule says that you have v du dx minus u div dx, all divided by v squared. That is the quotient rule. So if you are being asked to differentiate a function of this kind, the quotient rule says that the product of v times the differential of u minus the product of u times the derivative of v, all divided by v squared. So if you have so we have y is equal to 2x plus 2 on s cubed minus 1. And you have to find the derivative of the function. You have to find the derivative of the function. So let's solve it. We have y is equal to 2x plus 2 on s cubed minus 1. We are being asked to find the derivative of this function or differentiate y. Now you can see that this is what? A quotient function. So what you have to do is use the quotient rule. So in using the quotient rule, you have to state it. Let the numerator be, let's say, u, and the denominator be v. So from this, u is equal to 2x plus 2 equation 1. And s cubed, that is our v, will be equal to s cubed minus 1 equation 2. And the quotient rule says that if you are using the quotient rule, your dy dx is equal to v du dx minus u div dx. So now we know that u is equal to 2x plus 2. Let's differentiate, find the derivative of u from equation 1. So from equation 1, and equation 1 is u is equal to 2x plus 2. So let's differentiate this. Du dx will be equal to 1 times 2. So if you differentiate this term, you will get 2. If you differentiate a constant, it's 0. Very good. From equation 2. From equation 2, v is equal to s cubed minus 1. So let's differentiate or find the derivative of this function. So the x will be equal to 3s squared. As I said, you multiply the exponent by the coefficient of x and you reduce the exponent by 1. So you have 3 here, reduced by that 2. So we have now finished finding the derivative. What next? Let's substitute the v dx, the u dx, u and v into the formula. So our dy dx will be equal to v. Then you write v. What is v? V is s cubed minus 1. So write s power 3 minus 1 times du dx times du dx. And what is du dx? Is 2. So times 2. As I said earlier on in mathematics, sometimes dot represents multiplication. Okay. So then you bring the operation sign. Minus v, and v is s cubed minus 1. So s cubed minus 1 times du dx, and our du, the first good. So v du dx minus u dv dx, and our u is 2x plus 2. So write 2x plus 2 dv dx and dv dx times 3x squared, all divided by v squared. So all divided by v squared. What is v? V is s cubed minus 1. So s cubed minus squared. That is how you use the quotient rule in differentiating a function of set kind. Okay, so illustrative example 2. We have y is equal to s squared on y plus s cubed, all roots. Find dy dx. So you have to differentiate this function. We are still using the quotient rule. It says that your dy dx is equal to v du dx minus u dv dx, all divided by v squared. Meaning that before you can use the quotient rule, you have to find du dx minus dv dx, because already we know our u, we know our v, we know our v already. So what you have to do is find du dx and dv dx. So now, looking at our question is y is equal to s squared on 1 plus s cubed, all roots. So let our u is equal to the numerator and our v is equal to the denominator. So we say that u is equal to s squared. Let's name it as equation 1. Our v is equal to 1 plus s cubed, all roots. As equation 2. So from equation 1, say that from equation 1. From equation 1, you have du dx. Du dx means that you are differentiating u with respect to x will be equal to the exponent times the coefficient of x. So 2x, and the exponent will reduce it by 1. That is for u dx. Let's come to v. For v is equal to 1 plus s cubed all root. Now, square root is affecting the whole thing. So our v is the same as 1 plus s cubed all exponent 2. Square root is half. Take note. So we can change the square root and use the 1 out of 2. So I think we can differentiate this function. Remember, we just did product rule and chain rule. That's function of functions. So our dv dx will be equal to the exponent here, that is 1 over 2, times the derivative of the inside term of the bracket. So let's differentiate the term inside the bracket. So you get 3s squared. Then you write the terms inside the bracket. 1 plus s cubed. Then you reduce the exponent by 1. So you get negative 1 over 2. Let's continue. 1 over 2 times 3s squared. So dv dx will be equal to 3 over 2s squared times 1 plus s exponent 3 negative 1 over 2. Dv dx will be equal to 3s squared all over 2. We want to get rid of the negative exponent of this term. So it's going to be 1 on the whole of 1 plus x exponent 3 or exponent 2. And don't forget, if you multiply 1 by this, you get the same answer. So your dv dx will be equal to 3s squared over 2 bracket opened 1 plus s cubed 1 over 2. So our dy dx will be equal to, already we have stated that dy dx is equal to v du dx minus u dv dx. All divided by v squared. So if you get to this point, all that you need to do is substitution. We've gotten our v, we know our dv, our du dx, we know our u, we know our dv dx, and we know our v already. So let's do the substitution. So dy dx will be equal to v. What is v? Let's come back. V is what? 1 plus s cubed all root. So we can use that one for v. So v is 1 plus s cubed. This is the exponent 2. We can use this one as the v. Du dx. What is du dx? Du dx. Our du dx is 2x. So let's multiply by 2x. Let's bring the operation sign. Minus u. And our u is s squared. So s squared. Times dv dx. And our dv dx is just here. So times 3 over 2 s squared bracket will be 1 plus s cubed 1 over 2. So we have dy dx will be equal to 1 plus s cubed 1 over 2 2x minus s squared times 3 over 2 x exponent 2. So So you get 3x squared plus the 2. That will give you 3x exponent 4. So you get 3x exponent 4 over 2 bracket 1 plus x exponent 3 over 1 over 2. So our final answer, our divide with x, will equal to 1 plus s cubed 1 over 2 2x minus 3x exponent 4 all divided by 2 bracket 1 plus x exponent 3 bracket close 1 over 2. Second derivative. Now if you have, let's say y is equal to 8x exponent 4 plus 2x exponent 3 plus s squared. They ask you to find the second derivative of this function. It means that after differentiating, continue to differentiate again for the second time. So for second derivative, after differentiating or find the derivative of the function for the first time, differentiate once again for the second time. And that's what we call second derivative. So for second derivative is, before we come to this one, let's say we have y is equal to s exponent 4. If you have y is equal to s exponent 4, then your dy dx is equal to 4x exponent 3. 4x exponent 3. But for your second derivative, your dy dx is written as d square y over dx squared. That is how you write it. Your dy dx is written as d square y over dx squared is equal to, let's differentiate this once again. 3 times 4 x, then you reduce this, you get 2. That's what we call second derivative. So let's come to this question. Y is equal to 8x exponent 4 plus 2x exponent 3 plus s squared. You are being asked to differentiate or find the second derivative of this function. First thing, differentiate this function first. So your dy dx is equal to 4 times 8. Just take your calculator, 0.4 times 8. It will give you 32. So 32 will be the coefficient. X, reduce the 4 by 1. You will get 3. Plus 3 times 2, 6. X is then 2 plus 2x. Now, let's go to our second derivative. Then you have the square y over the x squared will be equal to, let's start differentiating this one again. Let's differentiate once again. 3 times 32. 3 times 32. You take your calculator. 32 times 3. This one will be 96. So 6 x exponent 3 will become exponent 2 plus 2 times 6 will give us 12. X exponent 1 is the same as x plus 2x. If you differentiate it, you get 2. So this is what we call second derivative. So for second derivative, you divide x. You divide x is equal to the square y over the x square. For second derivative, take note. Try it. If divide x is equal to 13 x exponent 4 plus 5 x exponent 3 plus 2x squared. Find the square y over